Okay, good morning, good afternoon, good evening, good night. Welcome to the revision for Maths Paper 1, which is sequences and series. This is for grade 12. So, if your exams are around the corner, it's probably the last push now, but all the best. You can do it. Stay strong. You are almost there. It's almost done. Trust me, you will be just fine. But today we'll be doing sequences and series, revision for that. So I'll just make parts of videos. I just won't do everything in a single video because it would just be too long. But what I'll do is just do an intro for sequences and series, um, speak about what sequences and series are, and then methods, formulas, and things that you need to know related to sequences and series. And then I'll get into some past papers. But here is an overview of what we'll be doing essentially. Here's some questions, and yeah, that's it. But anyway, let's get started. So, what are sequences and series? So, a sequence is an ordered list of numbers that follows a specific pattern, right? So, each number in the list is called a term. So, if you're given the arithmetic, which is 2, 4, 6, 8, 10, 2 is a term, 4 is a term, 6 is a term, and 10 is a term. Same thing for the quadratic and the geometric, right? But now, what is a series? A series is the sum of the terms of a sequence. So that means if you're to add up all of the terms, that gives you the series, which is the sum of terms. So it tells us the total value that is accumulated after a certain number of terms, or sometimes infinitely. So that means maybe the terms, they never end, they just keep going on and on and on and on, all the way to infinity. So you see infinity by 3 dots over here. So if you see these 3 dots, so that means the sequence is up to infinity. Okay, so now understanding the pattern is the first step. You need to understand what type of pattern you are given so that you can be able to answer the type of questions or the questions that come after understanding what type of pattern you are given. Okay, so now why even bother mastering sequences and series? So this will be especially beneficial to you if you want to get into fields such as your accounting, engineering, and stuff like that. But this is only for interest sake. So if you're not interested in all this mumbo jumbo, you can just skip over to the part that has to do with questions and the theory based stuff. But now, sequences and series might seem abstract at first. They feel like, okay, what the heck is going on here? But now, they are the foundation of so many things in science, engineering, and even in finance. But now, in CAPS, or in IEB rather, they bridge the gap between your algebra and even stuff like functions and calculus, which is why they come before. So there's a reason why the theory or the syllabus is the way that it is. There's a reason why you need to understand sequences before you understand functions, before you understand even calculus, because you do need the knowledge of sequences and series in stuff like functions and calculus, right? So now you'll find sequences used in physics to model motion, waves, and growth patterns. In finance, to calculate compound interest. This is a very important topic that we do in financial maths. And in data and computer science, to represent repeating or recursive processes, right? So now, moving forward, we see physics and motion. There's actually patterns, sequences, and series for stuff like your what are they called, vertical projectile motions, but it's just very underlying, and stuff like wave functions, sound waves, and all those things. Even in financial maths, financial literacy, future values, present values, and even in calculus, stuff like derivatives and integrals. You see them if you're doing your much more advanced mathematics, and even in varsity as well. Okay, so now once again, this is just a repetition of the application of sequence and series, but let's see in real life what that looks like. So if you're given savings, so let's say you save 100 Rand every month, and your money grows by a constant difference. So let's say you save money January, February, March, April, May, but you're adding 100 Rand every month. So in Jan, you have 100 Rand, Feb, you have 200 Rand. So the difference between the two amounts is 100 Rand, right? So this is a steady rate, and it is shown by the arithmetic sequence formula, okay? So now in the quadratic curve or quadratic pattern, we see this in motion. So let's say you throw a ball into the air, or you swing a ball. So this is all governed by something called gravity. You should know gravity by now. And this follows a parabolic path. So this is where we see something like this. And you see the ball goes side to side, side to side. So this is where the quadratic pattern comes in. Geometric growth. So if we are to talk about if a bacterial population doubles every hour, it exhibits constant ratio. So this boils down to life sciences. You know, you've learned about bacteria, you've learned about viruses. Is it fungus? Yes, you've learned about that as well. So here they speak about the growth, it doubles every hour. So meaning if you had bacterial population of 100, and then every hour it is from 100 becomes 200, or maybe you start with 200 and it doubles, it becomes 400. From there it becomes 600 and stuff like that. So that is governed by geometric patterns. Okay. Right, so this is just a repetition of where you would see this. So in science and engineering, bouncing of balls, calculating how long it takes for your phone battery to drain at different usage levels. So if you use your phone for the entire hour, how will the battery drain? If you use your phone maybe 5 minutes per hour, how will the battery drain? Sound waves as well, those are governed by patterns. So people that study music, they understand rhythms and beats, so that is also governed by patterns. So finance and economics, so here we talk about compound interest, determining the cost and the payment schedules for a loan, and annuities, predicting future salaries. If you want to know how much you're going to earn, maybe if you're working at a certain company, you want to know how much you're going to earn after 10 years, you can do that calculation because of patterns, because of sequences and series. And data and computer science, this is what I'm studying, computer science. So stuff like understanding the social media growth, or algorithms rather. How do you know the next video? How does your algorithm know which video to show you next? So this is decided by patterns, maybe stuff that you've been watching. That's how you get to know, okay, next video is probably going to be a dance video or something like that. And why your phone gets slow when you have too many running apps, especially Android. Oh my goodness. The lower quality versions of Samsungs, they will run slow if you have too many apps. I used to use an Android Samsung, I think it was A something. I did not have a good time, okay? And how streaming services like Netflix predict what you will want to watch next. So this is all based on data. Data is collected, and then patterns are formed or studied to be like, okay, cool, so this person would like to watch this next. They like cartoons, they like sci-fi, so we're going to show them sci-fi next. Okay. All right, so this was just the basic introduction of the things that have to do with sequences and series, why you should learn about it, its importance in the future. Because I know when you're in grade 12, you're like, oh, I'm not going to need to use this. If, of course, you're not going to go into the fields that I mentioned, it makes sense why you wouldn't want to watch or learn about that or pay too much attention to that. But that's fine. Next video we'll be starting with the grade 12 theory, what the formulas are, so do stay tuned for that. And yeah, happy studying.